Thank you. Thank you. Wonderful class. So today what we want to talk about is using the law of cosines. Let's write down the fact that when you use the law of cosines, the big thing is this: if you do not have a pair of opposites, which is the law of sines, you're going to be forced to use the law of sines. So you use the law of sines when? So you're going to use it when you know, if you know a side angle side, you can get the opposite side, or if you know side, 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 you can find an angle, all right? We have two different formulas that we've seen. One is the opposite squared is equal to adjacent squared plus adjacent squared minus 2 times adjacent times the cosine. That will give you the opposite side using the law of cosines if you know the side angle side, okay? The other way to formulate the law of cosines is if you know side, side, side. If you know all three sides, you can find the angle, and you would set up as cosine of theta is equal to the adjacent squared plus the adjacent squared minus the opposite squared divided by 2 times the adjacent times the adjacent. But since you're looking for an angle, right, Ryan? Since you're looking for an angle, you have to use the cosine inverse, right? Now, a big thing before I even teach any more of this, I said parentheses. It is imperative. You remember parentheses, because if you don't, in your calculator, remember parentheses, you need to make sure that you're going to divide the entire top expression by the entire bottom, and if you forget those parentheses, all you're going to divide is this opposite side by the 2. Okay, so it's really important in your calculator you remember the parentheses divided by the parentheses, otherwise you're going to get a really bad answer. Okay, so let's use these formulas. Let's take a look at example number 1. So first of all, there's not a pair of opposites, but I do have side angle side. And if that's the case, if I look at my formulas, I should be able to find the opposite side. So I should be able to find the opposite side. So this is little p. So to find little p, we'll set up the law of cosines. So we'll go opposite squared, which is little p squared. Opposite squared is equal to adjacent squared, which is the 10 squared, plus the adjacent squared, which is the 12 squared, minus 2. 2 is in the formula, times my adjacent side, which is 10, times my other adjacent side, which is 12, times the cosine of 84 degrees, okay? And I'm just going to use my calculator to figure that out. Remember, degree mode, it's got to be degree mode, right? Got to be degree mode. Otherwise, you're going to get a bad answer. So we're just going to type it in. 10 squared plus 12 squared minus 2 times 10 times 12 times the cosine of 84, okay? And I get an answer, 218.913 blah, 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 right? But that's not p, that is p squared, right? So p squared is equal to 218.913 blah, 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 blah. So obviously we're going to take the square root of that for your 218.9 square root. Answer, and we get about a 14.8, okay? So I'm going to put my 14.8 up here where p is. So let me write that in. 14.8. Now, it says solve the triangle. So there's a few things I still need to find. Now, at this point, everybody should agree that given the choice of the law of sines or the law of cosines, the law of sines is easier, right? And now we have a pair of opposites. So once you get your pair of opposites, let's just use the law of sines. So I'm going to circle my pair of opposites, right? There and there. And then I could find another pair of opposites. So what's up there that I could find? Think opposites. What up? Okay. Do you see anything that has an opposite that maybe I've got an opposite here? Angle G. Do you see on angle G? You got a pair of opposites. 10 and angle G. I could find angle G using the law of sines. So 2 days ago I told you when you're going to use law of sines, always write what you're going to find first. So I need angle G. So I'm going to go sine of G, right, over 10 equals the sine of 84 over 14.8. Okay, so I set up my law of sines. Opposite, sine of G over its opposite side equals the sine of 84 over its opposite side, okay? So cross multiply Sam, bring up the 10. Right, Sam? So I got sine of g is 10 times the sine of 84 over a 14.8. Now I'm going to get a weird answer because I'm looking for the sine of g, so I should get a decimal answer less than 1. Yeah, 10 sine 84, close your parentheses, divided by 14.8. So I do get a decimal, but I want to find the angle, right? So that's the sine of it, so I sine inverse, right? I'm going to go sine inverse that answer, and I get about a 42.2 degrees. Okay, that makes sense. So angle G is about a 42.2. Okay. All right. Okay, what do you think we should find next?
Angle I.
Yeah, that's pretty easy, right? We don't need to do anything fancy. We can go back to geometry to do that. You could. Law of sines will work. I'm going to go 180 though. Minus, no. Ryan, you're totally right. There, you're on film. Me saying you're totally right. Do you like that, Ryan?
Absolutely.
I know. It's been recorded. Ryan, you're absolutely right. However, I'm just going to add up and subtract from 180, right?
Children are going to watch this.
And they're going to say Ryan is always right. And the children are going to watch this, right? So I get about 53.8. Is angle I, okay? How's that? We got 1, 2, 3. We got all 3.
Wait, what's angle I?
Okay, not too bad. So obviously we like the law of sines the best. One thing to be careful though, okay, guys listening? If you take a look at the unit circle, okay, it's real important. See the unit circle, remember we did the unit circle, we did sine inverses? The unit circle gave us for sine answers here and here. So the law of sines, we could get negative angles. Well, that doesn't make any sense on a triangle, right? And we could get angles all the way up to 90. However, in a triangle, it's possible to have angles bigger than 90, right? So if you're ever going to find an obtuse angle, you have to use the law of cosines, okay? And we're gonna see that later, okay? If you know it's an obtuse angle, do not use law of sines, because law of sines will only give you an angle between 0 and 90. If it's bigger than 90, you're going to have to use the law of cosines. Okay? That circle keeps coming back, doesn't it? All right, now, example 2. So, right at the bat, my suggestion is to find angle T first because it's bigger than 90. It's an obtuse angle. If you use the law of sines, you will not get an angle bigger than 90. But you can use the law of cosines. Well, how does that work? Let's see. We had, in our notes, it says if you know side, 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 we can use the law of cosines, right? So I'm going to set it up. So I'm going to go, okay, cosine of t is equal to parentheses, all right? Parentheses. I'm going to go adjacent squared plus the other adjacent squared. And it doesn't matter the order, adjacent 1, adjacent 2. It doesn't matter. Minus the opposite squared, which is 15 squared. Parentheses divided by parentheses. We've got to have parentheses in there. We're going to go 2 times my adjacent, which is my 10, times my other adjacent, which is 8. Okay, now we should get a decimal, right? Because we're going to try and find the cosine of an angle. We'll have to do the cosine inverse. But first, let's go ahead and put that in my calculator. So it's really important, these parentheses. Slide that, you can see it. It's really important you go parentheses because you need the entire top. 10 squared plus 8 squared minus 15 squared parentheses divided by parentheses 2 times 10 times 8, right? And sure enough, I get a decimal. And I got a negative decimal, and of course, believe it or not, that makes sense. This circle, we keep coming back to the circle, right? Because if you have a negative x value, guess what? You're going to get an angle that's bigger than 90. That thing is powerful. That's why I made you learn it. So we go cosine inverse. So we go cos inverse of that answer, and I get an answer of about 112.4 degrees. So angle T is about 112.4 degrees, okay? Right, so this decimal is cosine of t equals a negative 0.38125, right? So how do I find the, you got it, Gary? Alicia, with me? Then you just cosine inverse it, right? Yeah, I got it, okay. So now, I got 112.4 degrees. So now, can I find A or C? Sure. And how about the law of sines? It's easier, right? If I have my pair of opposites. Okay, so Sam, what do you want to find? A or C? It doesn't matter. C it is. So we're going to go sine of C over 8 equals the sine of 112.4 over 15. Now you can take the sine of a obtuse angle, but you'll never get an obtuse angle with sine. Okay, I'll say that again. If you want to find an obtuse angle, you will never get it with sine. But if you want to use it, you can. Okay, now we're going to cross multiply, right? Bring up the 8. So I'll have sine, bring the 8 up there. Sine of C equals 8 times the sine of 112.4 over 15, right? Use my calculator. I'm going to get a decimal, right? You guys agree? I should get a decimal answer. 8 times the sine, 112.4, close your parentheses, divided by 15, and I get a decimal, right? Which I expected. And then what do I do to get the angle? Sine inverse of that answer, right? And so I get about a 29.5 degrees. So angle C, got angle C is about a 29.5 degrees. Okay, so I can put that in. Okay, now Ryan is probably going to use the law of sines to get angle A, because he's a mathematical genius. Me, I'm just going to add up and subtract from 180, okay? So for angle A, I'm just going to go angle A, 180 minus my 29.5 plus my 112.4. Let's see what I get. There you go. Parentheses, 29.5 plus 112.4. At about 38.1. So angle A is about 38.1 degrees. Okay, not bad. So, real quick, if you know side, angle, side, use the first formula, right? If you know all three sides but no angles, use the second law of cosine formula. Okay, return the page.
38.1.
Yeah.
Yeah.
Okay, let's go. Alright, now, on the back. So there are two ways to get the area, okay? There really are. There are two ways. One is to find an angle. You can get the angle, and then what you can do from the angle then is use the area formula. So I could go 1/2, 13 times 12 times the sine of the angle. That will work. And a lot of times if you're asked to solve the triangle, you have the angle anyway, okay? The other is Heron's formula. So there's two choices. Let's use Heron's formula, because then there's less work. You okay with that? So Heron's formula, let's see. First of all, we need to know the semi-perimeter. So that's going to equal, S is equal to 1/2, 13 plus 12 plus 11, right? Did you guys already get it?
Yeah, it's 18 is the semi-perimeter.
Okay, so I've got 13 plus 12 plus 11. You guys already have the answer, 18. Yeah, I should just listen to you. S is 18. Okay, you guys agree with that? And now the formula says just do this for area. You're going to use your big square root. S, which is 18, so I'm just using this formula right here. Okay. There we go, we can see it right there. Area is equal to my 18, that's my S, times an 18 minus 13.
So it could just be any side?
It could be any side, because you know as far as the order, right? Yeah, any side, totally right. Times my 18 minus 12, times my 18 minus 11. Do you guys agree with what Jose said? It doesn't really matter the order, because we can multiply in any order, right? Yeah. So anyway, I can simplify a little bit, right? 18 times 5 times 6 times 7, right? I just subtracted. All right, so now let's just do it. Square root, and I'm going to go then 18. Oh, hold on. Back up. 18 times 5 times 6 times 7. Close the parentheses. It's about 61.5, okay? 61.5 centimeters squared because it's area, right? Okay, so page 520, 9, 10, 16, 23, 33, 30, and 39.